Let me just invite my people. All right. Good afternoon once again. We're going to just like we already started capacitor and all that. We have started this thing from the very basic electrostatic. So and we're here to just solve one or two questions in addition to what we have done before. So we're going to be we'll continue from where we stop. Actually, continue from where we stop. Sorry, I'm trying to check if my system. Yeah. Good afternoon. I celebrate you. Welcome. So we're going to continue from where we stop. And please, I don't want you to forget most of what we have discussed already. They are very vital. They are very important. They are very, very, very important. Yeah, they are very, very, very important. This, no matter the little time that we have to share before I step out. Don't forget what I told you about capacitors. While we're on it, capacitors. I say capacitors can be connected either in series or in parallel. Now, I'm going to exemplify something that will help you to answer some theoretical questions. Just like I told you that we have different type of capacitors. Different type, we have parallel plate capacitor, which is the jam center of attraction, AOC, area of concentration. They're not going to give you question on cylindrical capacitor or spherical capacitor. They won't give you any questions on that, actually. Always dealing with parallel plate capacitor. As you can see, this is it. This is the arrangement. They are parallel plate. That is a capacitor is an arrangement of this nature where if here is negative charge, this will be what? Positive charge. Remember, there are equal and opposite charges. So this is the distance between the parallel plate. And I said this distance is made up of what? A dielectric. I said that in my when we were doing small revision in the morning. So, and that gives us our distance. You can call it distance, but the material is dielectric. Please don't forget the essence of dielectric in a capacitor is to increase what we call the what? The capacitance. Capacitance. As you can see from this arrangement, they are not going to this arrangement, you see that your charge is proportional to potential difference. That is the first thing that you need to know. That increase in charge increases what? Potential difference. Potential difference is not that thing than the work done and the terminals of a cell when the cell is what? Delivering current to the external load, or when the cell is what? Cross-circuited. Now, when you remove this, you see that Q equal to CV. That becomes formula for charge, which you can say, okay, C equal to Q over V. And you see, this is one of the jam question. You saw it that time now. While we are going through something, you see there was a question, there was something of that particular nature. So we are going to actually um, take questions because the essence of this class should not be jeopardized. I want it to be question, revision, everything. So any questions that we come in contact with, I remember where we stop. Before I get to other past questions, I will still have to pick one or two questions, draw it out in such a way that you will see it very well. And then we solve from there. Except if it is not a calculation question, if it's not a calculation question, then I can see how to, you know. Now, there are some tactical questions that we solve. This like this question now. Look at this question number 6. Question number 6 where we stop. They say which of the following, please watch, which of the following combination of 2 microfarad capacitors. Capacitors will give an effective, this is JAM question 1988. Give an effective, we give an effective capacitance of 3 microfarad or more across terminal X, Y. Are you seeing? Look at option A. We are going to work closely with this. They give us, here is X, which is this point to this. Okay. We have this and that to this. We have this again. This to this. Point Y. So from here. Remember, each of them, this is 2 microfarad. 2 microfarad. And here is still 2 microfarad. Okay, let me put it inside. 2 microfarad. Then B, we have X, this point X moving to, okay, this is it. Yeah, point X, then to this, and this give this, which further come here to give this. And oh no, let me give this and this. This is your point Y. Remember, C 2 microfarad. 2 microfarad. 2 microfarad. Then 2 I'm getting 2 I'm getting someone should signify if you can hear me, please. Can you hear me? Please just signify. Please, if you can hear me, just signify. Let me see. Okay, this is the question. So, oh, please, can you hear me? Can you hear me? Can you hear me? Yeah, please. Can you hear me now? Someone should just type. If you can hear me, please just signify. Send emoji. Let me know that you can hear me. Or type yes. If you can hear me. All right. But you can hear me now. I'm strong. Can you hear me? I'm strong. Can you hear me? All right. All right. All right. So now let's do this. Like that particular question I pick is question number 6. Yeah, that is question number 6, 1988. Now, if you look at this, the question says, which of the following combination of 2 microfarad capacitor will give the effective capacitance of 3 microfarad across terminal XY? Which of the arrangement that when you calculate, you have the effective capacitance as that? Are you seeing it? So that is what the question is all about. So we are going to look into all of them. Now, for you to solve A, or what should be the effective capacitance in A, let's check A. One solution now. Now, solution for A. Yeah, for A. I hope you are seeing A very well. We have these two, all of them are 2 microfarad, all the 3 capacitor, each is 2 microfarad. Now, but you see here, the first thing you have to do here, that is why I said, see, imagine now others we have been solving, other question we solve while we are in our morning life session is that we have to connect the parallel first. But this one, you have to connect the series, and the series will now be in parallel with these 2 microfarad. Are you seeing it? You have to connect the series. So you are going to have here in A that 1 over CS equal to 1 over 2 plus 1 over 2. Half plus half is 1, which implies that 1 over CS is equal to let's say 2 over 2. So even if you cross multiply, you see how that CS equal to this 2CS equal to 2 times 1, which is 2. This implies that CS equal to 2 over 2. That will give you that